Hello, and welcome to today's lesson. In this lesson, we are going to define the centroid, okay, another point of concurrency in triangles, and define and apply the centroid conjecture about the distance of lengths, and then find the center of gravity of a triangle. Okay, quick review from lesson 1. The angle bisectors of a triangle create the incenter, which is equidistant from the triangle's sides, and is the center of the inscribed circle. So it's an inside circle, equal distance from all of the sides, and that is the incenter. The perpendicular bisectors of a triangle create the circumcenter, which is equal distance from the triangle's vertices, and is the center of the circumscribed circle. Apologize for the writing there. Okay, so that circle touches all of the vertices, but is outside of the triangle. So that's what you want to remember is the circle is outside of the triangle in the circumcenter. The circle is inside the triangle when we have the incenter. And then we had our third point of concurrency, which is the altitudes of the triangle create the orthocenter. Okay, once again, not anything special about the orthocenter, doesn't find any special point of concurrency for us, but today we are going to find the new piece that we have. The medians of the triangle create the centroid of the triangle. So when we talk about medians, remember what a median is. You know, we are equal distance from vertices. Okay, so each one of these, when we're finding medians, we're cutting the side length in half, connecting the vertice with the side length. Cutting the side length in half, and then connecting the vertice to that median point. Okay, now, when we look at the centroid gives us some really good information mathematically about distances in a triangle. The centroid of a triangle divides each median length into two parts so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint. So what happens is these lengths are being cut into a 2/3, 1/3 ratio. So if we think about the fact that this 10 centimeter length is the 1/3 ratio, then the 2/3 ratio has to be 2 of the 10s, or 20 centimeters, and the entire distance overall ends up being 30 centimeters. And that works with all of the median lines. The longer portion, centroid to the vertex, is 2/3 of whatever the distance is, and from the centroid to the median point is 1/3 of that distance. So now, let's test and find some values. We're told that BC is 16 inches. So now we remember that 16 is a 2/3 measurement. So the 2/3 equals 16. And if we want, we can set up a ratio to find the full distance. So if we want to find the full distance AB, we can just set up this ratio. 2/3 is equal to 16 over x, and then we would cross multiply. 2x equals 48, and x equals 24. Now, that's one way to find that distance. Okay, the other way to find distances in this shape is just remember that this 16 is 2 parts, is the 16. So let's find out what 1 part is. We just divide both sides by 2, and 1 part equals 8. And now we know what this next distance is, because remember, it's a 2/3, 1/3 ratio. So you have 2 parts on top, 1 part on bottom, and then we can add the side lengths together to get the full distance of the median. Okay, just one more example here, and we'll finish up. So we've got AC is 3, and remember, AC is the 1/3 part, so it is just 1 part of the length equals 3. So now if I want BC, I want the 2 parts. So if 1 part is 3, then 2 parts has to be 6 for that length. And then if we want, so let's fill in BC is 6 centimeters. And then AB, we now have the pieces that we need, and we can just add those pieces together to know that the full length is 9 centimeters, which makes sense because the full length is 3 parts of that length. So we have the full 3 parts, we have the 1 part for the short side, we have the 2 parts for the long side. So you really want to think about how these values work together overall. Okay, last one, we've got AB. We've got the full length is 12. So our thinking on the side is the 3 parts that make up that full length equal 12. So then the 1 part is 4. Okay, so we've got our part pieces and we have our whole pieces. And now that we know that the 1 part piece is 4, we know what AC is, because AC is the 1 part piece. And BC is the 2 part piece. And I almost made a mistake there, right? Small writing mistake, working too fast. You always have to be careful of that. Great way to test your answers when we're looking at this situation. So BC is 2 of the parts, so 2 times 4 is 8. And then once again, we want to add them together and see if we get the full distance overall. Okay, now the centroid is also the center of gravity. So if you wanted to balance a triangle, what you would have to do is, if you could find the centroid, you could balance a triangle on a point. Mathematically, if we want to find the centroid, it is actually a nice, easy calculation. We want to find the mean, or what we also call the average, of the x's, the mean of the y's, and that is the balancing point or the centroid of the triangle. So first thing we have to do is find the average of the x's. -5 plus 3 plus -1. We've got 3 parts, so we have to divide by 3. So we have 5 plus 3, -2. -2 plus 1 is -3. -3 divided by 3 is -1. Okay, so there's the center of those 3 x's. And then the next thing that we're going to do to find the centroid is find the average of the y's. Okay, so our y values, -3 plus a -5 plus a 2, all divided by 3. So we have -8 plus 2 gives us a -6/3, which divides out to a -2. And once we find those 2 pieces, we have the centroid of the triangle. Okay, that concludes our lesson today. Good luck on the homework, and we'll see you soon.